Good morning, sir.
Good morning. करके मेरे
Morning, sir. Good morning.
Good morning. Good morning. Good morning. How is your health now? Good morning, Bedi. Hello, Dr. Bedi. How is your health now? Not looking well. Hello, Doctor. Please unmute yourself, Dr. Bedi. Hello, Dr. Bedi. Please unmute yourself. Trying me. Dr. Venkat, good morning.
हाँ एक राउंड आप मार के आ जाना फिर बाद में स्टार्ट करेंगे
Good morning, sir.
Good morning, sir. Bedi.
Can you hear me now, sir? अब आ रही है ना?
Now it's
Okay.
okay. Okay.
Yes, yes, sir. अब करिए स्टार्ट सर. Okay.
नमस्कार good morning once again good morning to you all so today is the 7th day of our 10 days training program and today we have again two eminent speakers first speaker Dr. Jasbir Singh Bedi. He is working as head of the department Center of One Health College of Veterinary Science Gadwasu Ludhiana and he is going to talk on regulation and risk assessment of chemical residues in animal origin foods. And today we have another speaker, Dr. Surinder P. Chawla. He is an ex-scientific officer, Food Technology Division, BARC, Mumbai. And the topic is on use of gamma radiation technology for extension of shelf life of meat. So both are very experienced and eminent speakers. So now I request Dr. R.J. Jhende sir to give brief introduction about our today's First, Dr. Bedi, sir, please, Dr. Bedi, sir, please.
Thank you, Dr. Vidya. Good, very good, warm morning to all of the participants. I think I could see now it is 147 number. Gradually, definitely it will. So I have pleasure to introduce Dr. Jasbir Singh. Bedi is the professor and director of Center of One Health Guru Angad Dev Indian Animal Science University, Ludhiana, Punjab. He will be talking on the topic assessment of chemical residue in animal. This is very important quality parameter as far as the export of the meat is concerned from our country. So Dr. Bedi is having about 17 to 18 years of the experience in teaching, research, and extension activities of the veterinary public health in Gadwasu, Punjab. Gadwasu. He has completed his graduation and post-graduation from the Ludhiana Ludhiana, and after that, as assistant professor in Gadwasu. So these are teaching and other appointments are made in various masters and PhD in the of the BPH. He is also the executive committee of Society of the Toxicology India. So that is why he is a so he's a member of the executive committee of the Indian Association of the Veterinary Public Health Specialists India, and his area of research interest is environmental contamination in the food supply, the human analysis of the and the analysis of the zoonosis as an essence of the director of this sector, as a course director, which are mainly sponsored by the ICAR, the latest training on the epidemiology in veterinary research. Has carried out in the last year during 20 to 29th May 2020. Yes, at his credit, there are awards to know some. There is he is a recognized fellow of the Indian Association of Veterinary Public Health Specialists, IVHS, Mumbai. He's a best research award he received in 2018 from the university. He was also awarded in research year, research paper. Is also the award of the distance learning program for the masters in veterinary pathology and public health. He is also the research scholar in USA and for infectious diseases, Virginia Polytechnic Institute and the State University, Black Virginia, USA, from the September to January. The VMB is award in 2013. Is awarded for the PhD degree program. Outstanding State Veterinary Alumnus Association in 2008. He also the recipient of the Young Scientist Full Travel Grant Award by the Department of Science and Technology, Government of India, to attend the international conference held at University of London in 2008. And there are many best oral and poster presentation awards at his credit. He has published research papers about 95, review article 6, book chapters 3, manual 3, and booklets on the antibiotic resistance in, published in the year 2021. So with this a short introduction, I invite Dr. Jaspal Singh Bedi, head of the department and director to talk on the regulation and risk assessment of the chemical residues in foods. So Dr. Jaspal Singh Bedi, please. I request all the participants to please put on your cameras so that we snap, initial snap. Please start your videos. Dr. Karam Nasser, Akshay, Mohammad Nusin, Sakid Bhai, and Pandeji, Abdul Abrar Mullah. So please start your video.
All participants are requested, please start your camera, put your camera on. You can start. Bedi.
Okay. First of all, I'm very thankful to Dr. Zende sir for inviting me in this training program and giving a detailed introduction about my career, which I started from a veterinary graduate to the presently acting as a director, Center for One Health. And I also must congratulate Dr. Zende and his team for organization of such training program, which I think they are very essential and important in terms of the capacity building of the nation towards the food safety and other aspects which are related to the food itself. And at the outset, I'm also a little bit, am I audible, Dr. Zende? Am I audible to all?
Sir, you are audible.
Yes, sir.
Yes, sir.
Yes,
And
sir.
starting with some light mood, I am also a little bit jealous to see you in shirts because is it okay?
Yes, yes.
Okay. Because in northern part of India, we are struggling with a bit cold here for the last 3 weeks. And even we haven't seen sun for the last 3 weeks. And we are wearing multi-layers to protect ourselves from the very harsh cold. And similarly, the COVID-19 cases, they are also becoming at a very alarming state in Punjab. And even I recovered a few days back from the second episode of the COVID-19, and even in our department, we have 3 to 4 faculty members who are becoming positive for the COVID-19. So, but the courageous effect of Dr. Zende to arrange such type of events in this situation of the COVID-19, I congratulate him and his team for the this training programs. Sir, please allow me to share my screen.
Yes, yes, you can share.
Okay.
You can directly share, sir.
Okay. Is it visible, sir? Is it visible?
No. No, sir.
Just wait.
No, sir, it's not visible.
Wait, sir. Dr. Vilas, how can I share from this platform, Cisco? Move to stage, show myself view.
Sir, there is a share option is there. Sir,
It's not
the
visible, sir.
down share option is in the down share option is first you open the PPT on the
Okay.
screen and then click the share option down on the and
Just take a second. Entire screen.
share
Is it visible now?
screen is there. Do the PPT and then yes, it's coming now.
Sir. Yes,
Yes.
sir.
Okay.
Yes. Here it's
So is it visible now?
Zoom. Yes.
It is in now full. It is in now full slide mode.
But it
Sir.
is in the
Yes.
filing form.
Please put it on presentation mode, sir.
It is in presentation mode.
It's visible. Put it on presentation mode.
Is it visible now?
Yes, sir.
डॉक्टर विलास अब ठीक है? Anybody else can respond? Is it okay?
It is not in a full screen form.
I made it full screen.
Sir, please press F5, sir. So that it will be full screen mode.
F5.
Yes, sir. Yes, F5.
I pressed it. Okay. Sir, it is in PPT mode now, presentation mode. Dr. Vilas, it is in presentation mode. Yes. डॉक्टर साहब आपकी आवाज कट रही है.
We can continue. Okay. So it is visible to everyone now.
Okay. ठीक है सर. Okay, sir.
Ah.
So the topic which I have been assigned in today's training is about the regulation and risk assessment for especially the chemical residues in animal origin foods, and I will talk about in relation to its food safety aspect in the perspective of mainly Indian point of view. My presentation will be comprises of what is food safety, then what are the different hazards and risks associated with the food, then food regulations, risk assessment, and then I will conclude with some with some papers which we have contributed towards the risk assessment from our lab. So basically, if we think about why we need regulations and risk assessment in the present scenario, and you will be surprised to know that that human population, if we see, there are some factors which are contributing that we need a lot of concern about the food safety in India as well as in the for the consumer health and for the trade purpose. We have seen the exponential growth of the population, and by the 2050 it will reach to the 9.7 billion, which is a huge population, and especially this growth is basically increasing in the developing nations, and we are already facing some of the problems with the increase in the population. We have stress on the agriculture land. There are cases of the soil erosion, deforestation, then the emerging diseases threats, as well as the wildlife human interface contact. Okay, so we are already facing some type of these problems, which are again going to be increased by the in the coming years. And if we talk about to feed this population, the food production which is at during the 2012, we have to increase it by more than 50% of the food which is produced in the 2012 to feed the increasing population. In developing countries, the economy is rising as well as the per capita income is also rising. So when the per capita income of the middle segment increases, their demands towards the food changes. And this demand particularly goes with the increase in demand of the meat, dairy, fruits, and nuts. By 2012, around 30 billion animals they were slaughtered to meet the requirement of the food for the human beings. And if this population grows at this growth rate, we need to be slaughtered 15 billion animals more by the coming 2 decades. So I mean the demand is एक second presentation कर दूँ घंटा लग गया मैं उठे आना था So the demand will be increased as the income group of the population increase. And similarly, we have seen many disasters in the form of fires, in the form of floods, drought, etc., which make a pay for the pathogens, chemicals, heavy metals, and other pollutants. They can contaminate the area such as air, water, and the environment in which we live and we grow the crops. So by disasters, the food can be contaminated. And transboundary diseases, they are also becoming a top concern for the food safety and food security because they are very infectious in nature. And because of the globalization and increased travel, the diseases can be easily travel from one part of the world to the another part of the world.
The slides are not
Similarly,
moving.
Food preference slides are not moving.
No, sir, slides are not moving. We are stuck on first slide.
But from my side, it is clear. Dr. Vilas?
Sir, it's
No,
slides are not moving,
not
sir.
moving, sir.
So what we can do? Shall I send my presentation to you, Dr. Vilas?
Just once again, what you can do, you can stop the sharing and you can try. Yes, it's now, sir, it's now visible. Your second
Visible है?
slide should come.
It is 4. I am on 4th slide, Dr. Sahab. ये दिख रही है?
इथले
Is it visible, sir?
Yes, yes.
Yes, sir.
It's visible. Yes, sir. Fourth
Okay.
slide is visible.
Okay.
It is visible now.
Now the food preferences, they are also changing, especially in the metropolitan cities and the developed countries that we have seen. There are different segments for the organic food or the fair trade food or the increasing preference of the local grown food products. Now with the increase in incomes or with the increase in awareness that people, they are turning their food habits towards a more organic, fair trade, and locally grown food. So all these factors, they are making, you can say that they are making a base for the establishment of the legislation, regulations, risk assessment studies, or other food safety aspects. And this is a changing focus of the animal health. We can easily appreciate from this graph that during the early 20th century, the focus in the animal side was treating the animal diseases, and the focus was on individual animal with the least concern on the consumer, concern on the food safety and food quality. So during these periods, the main focus was on the treatment of the animal and we get the production from the animal.
Fifth slide of graph, it is not visible.
So Dr. Vilas, what I can do, I can send my presentation to you and you can play and I can speak. Is it fine?
Okay, sir.
Just wait for 1 minute.
Now it's visible. Your graph.
So I'm not able to understand
Vilas,
why it is not visible on full screen. Maybe some of the candidates, they have a poor
you
connection.
send you. Yeah.
I will send, I'm sending you, sir.
Then,
Yeah. Okay. Okay.
Dr.
Please, sir.
Vaidya, you can send it to Dr. Vaidya. They will show you, and you can speak.
Yes.
Okay.
Please.
COVID, sir. ठीक है ठीक ओके मैं कर दूंगा एक आपने नोटिफिकेशन डालूं बाकी वाला इनविटेशन होगा व्याज होता है ठीक है सिचुएशन होगी हम उठा काली आज पता फायदा ठीक है मैं अन्ना कर दूंगा मैं निकल पंकज यार प्रॉब्लम आ रही है थोड़ी इंदे विच Dr. Zende sir, I have forwarded at your email.
Okay. ठीक है.
Okay, sir. Okay.
Sir, I have sent.
Sir, is it visible to you, Bedi sir?
Yes, yes, it is visible.
From which side I should start, sir?
Fourth or fifth.
Bedi sir, from which side, which
Fifth,
slide I should continue? Fourth slide?
five, five.
Okay, thank you, sir.
Graph. Next one. Yes. So by looking at this graph, we can easily understand that the concept of the food health or the food safety is emerging for the last 100 years, for the last more than 100 years. So initially the focus was only on the animal treatment, and during the after the 1940s or around 1950s, when the population grew exponentially, and to feed this growing population, the focus was turned from the individual animal to the herd health or the flock health. And in this portion also, the concern of the food safety was increased a little bit. Okay, and when we were able to meet the demand of the growing population, now the trend is that we are more focused on the food production chain and the food safety aspect. So that is why we are in process of the standardization and certification of the herd health, food safety, and quality control management by implementation of the various rules and regulation in the food safety sector. And actually, the consumers, they are becoming more aware in relation to the food they consume, right? So this has taken a long way that the consumer, they develop concern about the food safety and food quality. And especially in the developed nation, the standardization procedure and the certification, they are very stringent, and they are very there are strict compliance. But in developing countries, the process of the compliance and standardization is still in incubation phase, or in it is in progress. So next slide, please. So the food safety nowadays has become a health priority. If we see these figures, which I obtained from the WHO, the food related illness, they are huge in the world. 600 million cases, they appear every year because of the food related issues, which could be because of the microbiological related issues or the chemical related issues. And every 1 in 10 people, they suffer from the food related issues every year, and more than 4 lakh people, they die. And among them, mostly cases, they are related to the children's. So around 40% of the cases, they appear in the children. And this is the world figure. But if we concern about the Indian figures, where we have poor surveillance and poor reporting of the food related illnesses, every 5th person, or every 5% in the 10, they suffer from the episode of the food related illness in a year. Every year, even the people, they suffer from the food poisoning, maybe from the vomition, diarrhea, stomach ache, etc. Every year we have a 1 or 2 episode because of the food related illnesses. And these, they are responsible for the huge economic losses to the country. It is estimated that around 15 billion US dollar we lost every year because of the food related illnesses. And if you see this heat map, which is related to the foodborne emerging infectious diseases, and this graph has been depicting the red areas based upon the population density as well as on the human population growth rate. And these are the hotspots where the diseases, they are emerging because of the food related illnesses. And these food related illness, they may be vary from a mild food poisoning to the form of a cancer because of some of the carcinogenic compounds which are present in the food. And around 200 ailments have been identified which are related to the food or the food products in the human beings. Next. And if we see the Indian scenario, we have a rich traditional culture of the food because if you see this map of India, you will find traditional dishes everywhere, which are which are particularly pertain to the local areas, and a famous food supply chain, which whole world gave example of the Dibba system in Mumbai. And all these, they are traditional things which we generally cook and prepare fresh, and then we eat, and they pose little hazard to the consumer. But nowadays the food preferences are changing. We are turning towards some more ready to eat foods availability. We have less time to cook. We depend upon the available food in the market. And in India, there is a huge unorganized chain for the food supply. And all these things, they are turning towards the more number of the episodes of the food related illnesses in India. And we have this system also where we go for the langar system in many areas where the food is distributed to the people who are needy, but with the least precautions related to the food safety. And all these kind of things may really lead to the food poisoning or the food related illnesses in India. And India, we have also a limited refrigeration facility or the chilling facilities for food. There is a high chances of the cross contamination of food because of the lack of the refrigeration system. So all these factors, they are leading towards the development of the emerging infectious disease hotspot in relation to the food sector in India. Next. So now we are talking about the food safety in each and every aspect. And the food safety, it is a kind of assurance that we get from the food industry or the food manufacturer that the food which is available is acceptance for the human consumption and according to its intended use. But when we talk about the chemical contaminants in the food, chemical contaminants may be present in the air, may be present in the water, food, or other sources, and they can find their way into the food. And we are not able to eliminate all the environment or the chemical contaminants in the food. So that is why it has been implied that these chemical contaminants, they may be permitted up to a acceptable level of their limits. It means the limits which do not pose any kind of the health hazard to the consumer, right? And food safety also ensure that the conditions and measures in the food chain, they do not represent any appreciable risk to the human health. For example, when we go to buy vegetables in the market, we usually ask to the farmers where these have been grown and what is the source of the irrigation, because we have seen the rising cases of the neurocysticercosis in the sewage irrigated vegetables. So we ensure that the vegetables which are grown with the sewage water, we prefer to avoid them or we do not consume them, so that we are giving emphasis on the chain of the food from which it has been emerged and how it reaches to the human beings. Next. Food hazards, they are defined as any biological, chemical, or physical agent or condition of food which can pose adverse health effect to the consumer. And these food hazards may be in the form of biological form, maybe bacteria, virus, parasite, protozoa, prions, etc. These may be some chemicals, for example, pesticides. Then the physical hazards may also be there in the form of broken glass, in the form of nails, in the form of cockroaches or insects. So all these kind of things which
calcium chloride use हुए. Calcium chloride use कौन? It is commonly used an electrolyte and has an extremely salty taste.
Please mute yourself.
All the participants, please mute water. It can also be used as a preservative to maintain. Don't talk in between. In canned vegetables.
Hello. Shall I continue?
And high concentration in pickles salty taste is not increasing in the food sodium content. Calcium use for calcium chloride use.
Okay. So next, please. So these hazards, I already told you, they may be microbiological contamination, fertilizers and pollutants. Some of the impurities in the fertilizers, they can also contaminate the food chain, and additives, colors and flavors, which are very fascinating towards the development of color or flavor in the food. They may also sometimes pose risk when their levels they are more than the permissible limits. Then the pesticides are used on the crops as well as in the animals for the prevention of ectoparasitic diseases and in the crops to increase the food production. And these pesticides, they can gain way to the food through the water, through the direct spraying on the crops, through the air, or through the soil particles. And similarly, drug residues or the antibiotics which are used in the animals for the treatment, their residues can appear in the milk or meat. And there is also concern of the some of the drugs which are not permitted to be used in animals, but their residues they may appear in the food of the animal origin. Then the naturally occurring toxic substances, especially in the aquatic foods, heavy metals from the industrial waste, they can make a way to the food chain. Then the processing, packaging, and labeling, that is also need to be taken care of because they may also make a source for the contamination to the food. And adulteration and misbreeding, which is very common during the festival season when the demand is increasing. Adulteration and misbranding of the food is also become enormous when the demand of the food product is increased. So all these type of the contaminants, except microbiological contamination, they are considered under the chemical contamination. Their limits should be regulated. They should not be allowed in the concentration above the maximum permissible limit, etc. So all these kind of the regulations are needed when we talk about the chemical contaminants in the food. So next. And how these contaminants they can find their way to the food. For example, the microbiological contamination they can gain access to the food basically from the animals itself, from their facilities where the animal housing is there, from the water, from the food handlers, or from the environment in which the food is being handled. Similarly, the chemical contaminants, they can also make their way to the food product through the animals. When we, for example, when we use antibiotics for the treatment from the fodder, when contaminated with the pesticides, when animal consume, it can release into the animal milk. Similarly, the water may be contaminated with the heavy metals or the pesticides which are being given to the animals, so their residues can appear in the food chain. The environment in which we are handling the food, for example, the labeling, the branding, then the contact surfaces, they can also become a source of the contamination to the food. And there is a very complex system for the pesticide entry into the human food chain. When the seeds they are sown, which are treated with the pesticides, then the crops which are being sprayed with the pesticide, soil particles from the water, all these sources can lead to the approach to the animals. And in those animals which have been given feed or fodder with the pesticide, and if the animals they are in milking, the residues will appear in the dairy products, and if it is for meat purpose, the residues can appear in the meat of those animal, and from there it can reach to the consumers. Okay, so understanding of the chain, food supply chain, or the source of the contamination is very important to make a strategies for the regulation or the control of the program to avoid the occurrence of these type of contamination into the food meant for the human consumption. Okay, next. For the safe food, these are the general 5 principles, which I understand they are more applicable to the microbiological contaminants. Basically, they give emphasis on the keep clean, people, surface, and the environment. We need to separate raw and cooked food because there are very high chances of the microbial cross contamination. Then we need to be very much careful about the cooking of the food, which should be ideally at more than 70 degrees centigrade. Then we should avoid storage of the food at the danger zone, which is considered to be 5 to 60 degrees C, and the potable water, which we use for the food preparation. These are widely applicable for the microbiological contamination, but for the chemical contamination, the strategy or the approach is totally different, because the contaminants, chemical contaminants, they usually do not get destroyed at the heating of the food, and many of the contaminants, they can enter at the end product site. For example, when we are packaging the food, some chemicals may be present over there. For example, we have seen the effect of the cooking on the pesticide residues, and we observed that there is a very minimum damage to the pesticide when we cook or boil the food products. So chemical contamination strategies is slightly different from the microbiological contamination. So next. So that is the reason why regarding the chemical contamination, the Codex Alimentarius Commission guidelines, standards and code of practices, they are advocated for the whole world. And this Codex Alimentarius Commission is a, you can say, joint body of the FAO and WHO, which involve the protection of the consumer health. Okay. During Codex meetings, the main topics of the concern are always veterinary drugs, pesticides, food additives, and the contaminants, which are generally discussed during the Codex Alimentarius Commission. And Codex is also very much concerned about the international food trade, because after imbibed with the WTO's agreement on SPS and WTO agreement, and the increasing global trade, there is a movement of food from one country to the another country. So for the importing countries or the exporting countries, they can follow the Codex Alimentarius Commission guidelines or the standards for the import or export of the products. And further, each country can also impose the standard for its own country, but that should be on basis of some scientific evidence. So Codex also, we can say, it removed the barriers to the trade between countries and also concerned about the protection of the consumer health. And if you visit the Codex site, that is giving a very detailed information about the Codex activities, its themes, its committees, its meeting, resources, publications, and everything. And more than around 189 countries or the unions, they are member of this Codex Alimentarius Commission. So internationally, for the consumer health and the international trade, Codex Alimentarius Commission is being followed by the countries. Next, please. And if regarding the Codex, sorry, I'm coughing in between because of sore throat, which I haven't recovered fully. The Codex maximum limits have been prescribed for the food and feed. And these are the maximum concentration of any substance which is legally permitted to that commodity. So for example, say the presence of DDT in milk. Okay. So presence of DDT in milk has a particular limit, which is known as a maximum limit or maximum residue limit. This is a limit which is permissible in the milk, and which is assumed that consumption of this milk do not pose any significant or any health effect to the consumer. And this limit is being followed by the countries when they are involved in the trade of the milk. And Codex, it has also committee on contaminants in food, especially committee on the contaminants in food, which establish and endorse the limits and the guideline values for contaminants and the naturally occurring toxicants. Along with this, Codex has a joint FAO-WHO expert committee on the food additives, which prioritize risk for the estimation of the risk assessment. Okay, so Codex plays a very important role in the regulation of the food when we talk about the international or the national point of view. Next. When you visit the Codex site, there you will find a different code of practices which are relating to the different aspects, which could be to reduce the contamination of food and chemicals, reduction of the heavy metals in the food. Then they also recommend the method for the sampling of the determination of pesticide residues for compliance with the MRLs, guidelines for the good laboratory practice in pesticide residue analysis, then the portion of commodities which you need to be sampled when you are going to analyze food products. And these code of practices, they are very helpful when we think beyond this theoretical topic of the food safety, because we are applying these code of practices and guidelines in our laboratories when we do the research related to the chemical contaminants in the food. So their understanding, their application, their utility is a very much important when we talk about the research and the food safety aspects. Next. And this is the global to national food safety system, which is acceptable at the each and every segment. It comprises 4 different you can say points. That is the international governance, where we already talk about the Codex, and on animal health, OIE, International Plant Protection Convention, and WTO. These are the international governance which deal with the food aspect in the maybe for the consumer health or for the food trade. And the country infrastructure, it is also very important in the food safety system, where we have some science-based standards, we have laws and regulations, and we have inspection and compliance. Okay, and this I will talk about the next slides of the country infrastructure, which we have in the form of the FSSAI. Then there are some voluntary.
Hello, there is. Please mute all the participants. Don't disturb the speaker in between.
But कम से कम आपको बताना चाहिए ना.
I will remove you.
ठीक है.
So along with this international governance, national regulations, we have also ISO, which is a voluntary, we can say food safety system, which is adopted by the countries. Next. Previous. So ISO is also being adopted by the many developed countries as well as the developing countries, which are having a very good infrastructure for the food production. Then the global food safety infrastructure is also becoming important for the food safety system, and the food safety management systems. We nowadays the food safety or the consumer, they are asking about the accreditation certificate or the transparency in the food safety system, which comes under the business initiatives. So 4 different segments are basically important in the food safety when we talk about the chemical contaminants in the food of the animal origin. Next. And if I talk about now about India, and after independence, the Prevention of Food Adulteration Act was enacted in 1954. And later on, various food-related act or order were passed, and which could be food product order, meat and meat product order, milk or food product order, or edible product order. So there were various laws or acts which were dealing independently with the food product for which they have been assigned. But in the recent past, in 2006, next slide, all these acts, they have been merged towards the Food Safety and Standard Act 2006. Okay. Now all the acts, they come under the umbrella of FSSAI, and now FSSAI has working on the food safety regulation, food safety standards, etc. in the India. So Food Safety Standard Authority is working very efficiently, I would say, towards the establishment of the food safety and standard in the India. Next. And after the establishment of FSSAI in India, if you visit the website of FSSAI, you will see that they have adopted the standards from the Codex Alimentarius. They have also adopted the best international standards available in other countries, and they have also evaluated the food safety regulations and standards in India. And based upon this mixing of the different standards, they have developed the Indian food safety regulations, which I will discuss in the next slides. Next. This FSSAI Act is a very strong, and it covers all the aspect of the food production in the food chain, right from the raw material production to the processing, to the transportation, and to the storage. And similarly, it covers every segment of the food chain, right from the street hawkers to the large the food product buildings. So it is a very strong covering all aspects of the food production as well as the food supply chain. Next. And these are some of the Food Safety and Standard Authority India regulations which have been enacted in 2011. And they comprising the food safety standard regulation, packaging and labeling, food additives, prohibition and restriction on sales, contaminants, toxin and residues, laboratory and sampling analysis. Okay, so there are different regulations which, when we visit the FSSAI site, we can easily see these regulations. And I'm talking about this FSS, Contaminants, Toxin and Residues Regulation 2011. Next. So in this regulation regarding the contaminants, which could be antibiotics, pesticides, food additives, etc. So to enact upon these regulations, FSSAI forms a panel of the expert committee on the different aspect of the contaminants. For example, the panel on pesticide residues have been formulated with these experts from the India. So FSSAI give an open call for the interest from the expert to become a member of the panel on the pesticide residues or some other contaminants. And then among those experts, they select 11 or 12 members in this board, which take decision on the different aspect of the regulation of the particular contaminants. So this food contaminant, toxin and residue regulation, if you go to the visit of this site, you will find around 120 pages information regarding the what are the different standards and the regulations which are related to the chemical contaminants in the food of the animal origin as well as the other foods. So next slide. Next. And these are the some of the manuals which have been produced by FSSAI, and these manual comprises all the details about the right from the sample collection to the analysis of the food for the pesticide residues. And this expert panel, they also they make a guidelines for the procedures for fixation of MRLs of pesticides in the food commodities. And these panels, they comprises the expert from the agriculture, from the veterinary side, both disciplines they comprises. Next. And these are some of the regulations regarding the presence of heavy metals in the food of animal origin. For example, lead, it should not be present in a amount 0.02 ppm parts per million of the milk. Okay, so for the trade purpose or for the distribution of the milk or for the sale of the milk, the companies who are licensed with the FSSAI, they have to give a labeling about the presence of these heavy metal contaminants, or they should say that their product contain the concentration of heavy metals below the recommended limit of the FSSAI. Okay. Similarly, for fish, cadmium, mercury limits are available. And when we do our research in our laboratories also, we compare our levels with the FSSAI regarding the heavy metal presence in the food articles. Okay. Next. Similarly, for aflatoxin, which is again emerging chemical contaminant, this is a limit. And the expert panel on pesticides, they have given enclosed a list of 213 pesticides which are covered by the FSSAI for the establishment of the maximum residue limits in the food articles. And you can see the milk and milk products, many pesticides, they have been given the maximum residue limits for the milk and milk products. Next. And in 2011 regulation regarding the antibiotics and other pharmacological active substances, only the limits were provided for the seafood, for the tetracycline, oxytetracycline, and trimethoprim. And these were their maximum permissible limits. Next. And these antibiotics, they are not permissible to be used in the meat animals. For example, nitrofurans, chloramphenicol, and sulfamethoxazole. And these are the recent regulations which have been incorporated in the FSSAI, depending upon the availability of data of these antibiotics in the food, as well as the potential hazard which they can pose to the consumer through the consumption of the food. Okay, and these are there, they should not be used anyway in the food production. And their limits, which are generally known as the extraneous maximum residue limits, which are the limits when we say that these products, they are not used on the animals, but their source may be somewhere from else, maybe from the feed, maybe from the water, or maybe from the environment. Even by considering these sources not essentially a treatment of the animal, their limits have been prescribed. Okay. For example, for chloramphenicol, the food product should not contain limit more than this 0.3 microgram per kg. Next. And if you visit this FSA site, or you visit this PDF file, you will find that in the recent last year, the antibiotic residues have been included for the food of animal origin, especially the milk and meat and fish. The Food Safety Authority of India has now incorporated the antibiotic residue limits in their regulations, which were not earlier available. Then how FSSAI works and how we can evaluate the functioning. There are different mechanisms. For example, food control management is there, food legislation are there, food inspection is there, food control laboratories are there, food safety and quality information we have to generate, education and communication is also very much essential. Dr. Vilas, please move quickly when I take this slide. First is the food control management. Next. So for food control management, the producer or the handler or the distribution, they have to get a license from the Food Safety Authority of India. They have to register and they have to follow the minimum good handling practices or the good manufacturing practices. And presently, food business operators, more than 350,000 have been registered with the FSSAI. So this is a kind of the food regulation control management program, which is covered by the Food Safety Standard Authority of India. Next. Next. Then the food legislation, we are slightly lacking in the compliance of the food legislation because of the lack of the human resources, lack of the infrastructure, and lack of the specific manpower, expertise manpower, which nowadays FSSAI is taking keen interest to employ the food safety officer at the district levels. Next. Please go through quickly. Inspection and surveillance. For inspection and surveillance, there are different directorate of enforcement and surveillance. They usually inspect the food outlets. They have a food safety officers, and presently the inspection and surveillance is focused on the detection of failures in the product, but unfortunately they are not based on the prevention of any contamination in the product. So when we generally seen during the Diwali season or festival season, the food safety officer, they go to the food shops, they take the sample and they inspect the sample and they give the failure rate of the food product in compliance with the food regulations of FSSAI. Next. Then we are also struggling to develop food safety laboratories. Presently, we have 4 referral laboratories, and FSSAI also asking the interest to develop food safety laboratory and accredited by the FSSAI. So we need to strengthen this laboratory and human resource for the development of the food safety laboratories. Next. We also need to generate awareness among the consumer. Then the concept of HACCP, good practices, they should be understood and they should be applied at the all segment where they are applicable. And there is a lot of information from the FSSAI website. Next. Now, FSSAI has also recently established the risk assessment cell with the motive to improve the food safety frameworks. They have RAC, risk assessment cell, and this risk assessment cell is working on ranking of hazards to determine which area of concern need to be addressed first and establishing the priorities based upon the public health as well as the economic and social aspect of the risk for its management. Because there are many challenges which we need to be addressed, but the risk assessment cell is working very hard to prioritization the risks which we need to be give priority for the control of the those risks so that they do not pose any kind of hazard to the consumer. Next. Now I will talk about a little bit about the risk assessment. So by looking at the figures, you can see that you can easily do the difference between the hazard and risk. So hazard is something that has potential to harm you. Okay, for example, मैं एक road पे जा रहा हूँ. Okay, and I know that the moving vehicles, they can pose harm to me. Okay, वो मुझे टक्कर मार सकते हैं and they can injure me, right? Okay, that is a hazard. And risk is the likelihood of a hazard causing harm. Means what is the probability that I may be hit by a moving car when I am moving on a road. Okay, so for risk, we have to develop a question that what is the probability of hitting by a car when I cross the road. or what is the probability of the hitting of the car when I am not walking on the pavement. Okay, so by indulging risk, we are calculating the chances of the probability of the hazards which we have already identified. Okay, so that is the risk. Okay, for example, we know that hazard, we know that salmonella in the eggs. Okay, I know that by consuming egg, I maybe get exposed to the salmonella. That is a hazard, I know. But risk is the, what is the probability that when I consume raw egg and I get salmonella? Okay, that could be a very high. What is the risk of a probability that I get salmonella when I eat wild egg? So in that case, the risk will be decreased. Okay, so risk is a very interesting, you can say risk assessment is a very interesting topic which covers the probability of the hazard to a human, okay, which helps in the prioritization of the hazards for the consumer. So next. And risk analysis is a very systematic approach. It is a holistic approach, and it comprises the 4 different segments. First is the hazard identification, risk assessment, risk management, and then the risk communication. Okay, so hazard, we already know that the chemicals, they may pose a different kind of hazard to the consumer. For example, related to the pesticide, I know that the consumption of the DDT with the milk may pose cancer to me. That is a hazard. Okay, and for risk assessment, I need to do the risk assessment studies, which will be a science based, which I cover in next slides. What is the risk to me from the consumption of the milk which is contaminated with the DDT? Okay, a risk assessment is a totally science based calculation, while the risk management is a policy based, that how we manage the risk. And risk communication is the way of exchange of information by the risk manager to the risk assessor and other stakeholders. So all these 3 segments, they are very well connected for the flow of information from one part to the another part of the risk analysis procedure. Next. Risk assessment, if I talk about, because we as a researcher in the Center for One Health, we are doing this risk assessment studies. Risk assessment for the chemical contaminants, it possesses 4 different parts. First is the hazard identification, which is the identification of any chemical which is capable of causing adverse health effects. Okay, which may be a mild form of the disease, or maybe some chronic form of the disease, or maybe some fatal form of the disease. Okay, so I identify the hazard. Then next will come hazard characterization. Okay, I need to characterize my hazard, which means what kind or what nature of the adverse health effects I have been exposed through this hazard. That is a hazard characterization, when we identify the nature of the adverse health effect, maybe mild form or a chronic form. Then exposure assessment, that I have identified a hazard, for example DDT, and what is the likely intake of DDT or antibiotics, or tetracycline, through the consumption of the food to me. That is my exposure assessment. Then risk characterization, that will be a quantitative or qualitative estimation, which will include uncertainties or the probability of occurrence. Okay, which will give me a value in a qualitative form or quantitative form, that this is a risk when I get exposed to this chemical contaminant, which is posing a severe health hazard to me. Okay, so I will explain in this in coming slide in some examples. Next. And risk management, that I identified that this chemical, for example, tetracycline is posing risk to me. It will affect my teeth, or it will affect my some body organs. So my risk management will be, I convey to the policy makers that this much residues they are coming and they are posing this risks to the consumer, and we need to manage this risk, which may be applied by the formulation of the maximum residue limits of the tetracycline in milk, or maybe prohibition of the use of the tetracycline or other drugs for the use in the animals. And then risk communication, that will be exchange of information from the different segments to the policymakers and to the different stakeholders, so that the flow of information can be made very smooth regarding the different aspects of the risks. Next. This risk assessment may be generally quantified, may be evaluated in two forms: qualitative risk assessment and the quantitative risk assessment. For example, this is the probability of occurrence of any risk, and these are the consequences of the that risk or the hazard. Okay. So if the probability of the occurrence of risk is very high and the consequences they are very high, then we can say that the risk of this condition is very high. Okay. For example, when we cross the road and without taking proper precaution or without following the light system, then the probability of hitting the car is very high. Okay. And the consequences, we know that during that accident, one can even injured or maybe some form of the fatal. So we can say that the risk of crossing the road without following the light is a very high, that it may turn to the fatal. So similarly, for food articles, we need to find out the probability and then we need to find out the consequences. Okay? For example, I know that the DDT, the probability of DDT occurrence nowadays is very low. Okay, but the consequences of its chronic intake, they are very severe. So my risk assessment will be that the intake of or the presence of DDT in milk, it may pose risk to the consumer. Okay, even the probability is very low, but the consequences or the results are very severe. Then even very low concentration can pose to the consequences to the consumer. Okay? So based upon these values, the quantitative risk assessment can be obtained. Okay? And for quantitative risk analysis, we need to follow some software or the modeling techniques, and we need to draw the decision tree analysis. We have to give the probability values at each and every point, and then we multiply those probability values, and then we were able to give a quantitative value of the risk in the form of the quantitative risk assessment. Next. And this risk analysis process is becoming very popular in the food safety industry. It is helping to formulate new standards. It is helping to evaluate the existing food standards, evaluating the existing food standards. It is also helpful to identify emerging food-related health risk and manage responses, and to evaluate the current technology practices. Okay, so this portion is becoming very, very important and critical when we talk about the risk analysis. And in India, the Food Safety Standard Authority, it although has a risk assessment cell, but I think it need to be go very beyond to become at par with the international risk assessment levels. Next. So now I will share some of the studies which we done on the risk assessment. Our lab is Dr. Zinde No, Mumbai and Gadwasu lab. They are both working on the chemical contaminants. We have lab facilities of gas chromatography for detection of pesticide residues. We have HPLC for antibiotics, AAS for the heavy metals, GCMS for confirmation. And during the last 15 years, we were able to publish more than 60 articles which are related to the chemical contaminants in the food. Next. First, I will talk about the pesticides. We know that pesticides, they are used on the crops and they pose a different kind of the risk. Okay, so we have identified the hazard now, and we know the exposure assessment that they pose a different kind of risk, carcinogenicity or birth defect, etc. Next. And for pesticides, these are the general guidelines which are recommended by US EPA model to calculate the risk assessment. And for pesticides, generally two types of risk assessments are calculated, non-cancer and cancer. Because many pesticides, they are considered to be carcinogenic for the consumer. Non-risk cancer assessment is generally calculated by hazard index, which is a ratio of average daily exposure, that is exposure assessment to the particular contaminant, divided by the benchmark concentration or the reference concentration which is given by the US EPA through their experimental studies. Okay, and we calculate these values, and generally it is considered that if HI is less than 1, then the contaminant do not pose any kind of the hazard to the consumer. Okay. For cancer risk assessment, we need to again calculate the estimated average daily dietary intake. Then we need to make a model of the exposure duration, which we generally consider average age, then the cancer potency factors, and then the multiply by a factor 10 raised to the power minus 6. And by getting this, putting value into this model, we get a quantitative estimation of the risk. And generally, the value of range from 10 raised to the power minus 6 to 10 raised to the power minus 4 is considered as a normal. So it means that when I calculate this risk, for example, for DDT, and it comes to be, for example, 0.23 into 10 raised to the power 5. So it means that there is a probability that 2 cases of cancer in 1 million population of human population may occur because of the consumption of the DDT contaminated with the milk contaminated with the DDT at this level. Okay, so that is my quantitative risk assessment, which I will show you next slide. Next, please. Next. Okay, this is the paper which we published in the milk. Okay, for the residues which were found positive in some of the samples, we calculated the average daily intake of those pesticides through the consumption of milk, which was calculated depending upon the what the levels we got in our milk samples, multiplied by the average availability of the milk to the consumer. Okay, so we estimated these values, and when we compare with the acceptable daily intake, all were below the acceptable daily intake values, okay, of the pesticides, right? And then we calculated the cancer and non-cancer risk assessment. And I told you that the hazard index, if it is less than 1, then we can say that it doesn't pose any risk to the consumer for a particular contaminants. And similarly, cancer risk factor was calculated 0.42 into 10 raised to the power minus 6 for 40 years age person. Okay, and this is for HCH, and this is for the DDT. So for individual pesticide, we have to calculate these values. Okay, which we need software, and we need a lot of calculation to reach to this level for the calculation of the quantitative risk assessment to the consumer. Next. Similarly, for infants, or the we calculated the risk to the breastfed child for different pesticides, and in some of the samples, the values were exceeded the provisional daily intake values for the infants. Okay, next. And from fish consumption, we were able to also calculate the values, and the hazard ratios, they were below the value of 1. Similarly, there was a very low or within the specified range of the cancer risk. There was no cancer risk. Next. And during the last 2 years, we have conducted research on the honey. And again, we calculated the risk assessment through the consumption of the honey. And the honey consumption, although it was contaminated with some of the pesticides, but it doesn't pose any kind of risk to the consumer. Okay, so this is the difference of the risk assessment calculation, that we know that these are the hazards. Okay, but without knowing the risk assessment, we will be giving lot of energy, lot of money towards the control of these compounds for the control of the residues into the honey. But by calculation of these values, we can easily appreciate that they do not pose any kind of risk to the consumer. So within the limited funds, I can now prioritize my funding towards a more challenging risk which consumers they are posing. Next. Similarly, we did for the antibiotic residues. Antibiotics, they can reach to the food and then to the consumer. Next. For antibiotics, we calculate the hazard index only, or hazard quotient. Next slide, please. And this is again, it's calculated by EDI over ADI, and the hazard quotient is less than 1. So this is within the range of the international or the national regulation agencies. We calculated both for the children and adult by assuming different age categories, and both they do not pose any risk to the consumer. Next. Again, for risk, we divided the risk from the different kinds of the farms because we generally presume that the large farms, they consume more antibiotics. So we calculated the risk assessment for different kinds of the categories of the farms. And again, the hazard quotients, they were found to be below the average value of the 1 for the consumer health. Next. And nowadays, the aflatoxin, they are also becoming a very major challenge in terms of the chemical contamination, or you can say the toxin contamination of the milk. And the recent past, next. And for risk assessment, this time we took help from our partner in the Royal Veterinary College London. And we did this risk assessment strategies by adopting the probabilistic approach method. And for this, we identify the aflatoxin M1 levels in the milk. Then we did the household survey for the consumer regarding the consumption of the milk and milk products. Then we did the exposure assessment by using this model. And we did this by using deterministic and probabilistic models. Deterministic models suggest that the values which were actually obtained during your analysis, for example, the mean values, they are applied during the deterministic approaches. And probabilistic approaches, when you apply the different probability occurrence of the contaminants in your sample, which you can apply as a binary form, which include minimum and maximum, or maybe uniform distribution when you apply single value, or maybe triangular when you apply the minimum, maximum, and mode of those values. And by putting all these values in the next, please, in the R software, and using the Monte Carlo simulation, we could able to assess the risk assessment through the consumption of the milk possessing the aflatoxin M1. Okay, and these were their values, and 5th percentile, 50th percentile, 95th percentile. This is we can say the mean probabilistic exposure assessment of AFM1 from the milk and milk products in the various different age groups. So this is the quantifiable risk assessment for the consumer. Next. Similarly, the aflatoxin M1 presence, it potentiates the the risk of the hepatocellular carcinoma. So by using one model, depending upon the prevalence of this hepatitis in country, we calculated the probability of cancer because of the aflatoxin M1 in the hepatitis positive patients. And by using this model and our software, we could able to generate data for the different age groups and different income groups, what is the contribution of aflatoxin M1 in the occurrence of hepatocellular carcinoma in the population. For example, the 95th percentile 0.0446 indicates that 4.4 or 4.5 cases of hepatocellular carcinoma in 10 raised to power 6 or 5 individuals are because of the aflatoxin M1 residues. Okay, so by this way we calculated the risk to the consumer, and we would be able to evaluate the quantity of the risk to the consumer. So this is all about the risk characterization or the risk assessment. Next. And nowadays the strategies, what I am telling you, has been changing from domain one sector to the one approach, and that is the One Health approach. Okay, now the problem solving is not specific, they are complex. Perspective of the problem solving has been changed from fragmented to the systematic approach, which is the risk assessment or ISO or the implementation of HACCP. Okay, from human illness, the shift has been changed to the origin of infection or the contamination, so that we can avoid the contamination. Single domain, we are working on the human, animal, environmental, three aspects of the this One Health approach. Okay, so nowadays the changes are being in place. Next. So regarding conclusion and summarize, I will like to conclude that in India, we have to travel a long way to meet the food safety regulation and standard as per the developed nation or the other Western countries. And for this, first and foremost need is to increase and upgradation of the food testing laboratories. Like Dr. Jende will agree that Mumbai and Gadwasu, they are doing on the chemical contaminants aspect in relation to the food safety aspect of the food of the animal origin. Although on agriculture aspect, a lot of laboratories are there, but for food of animal origin, these two laboratories are working, and we have to increase these laboratories, and we need to upgrade those laboratories with the modern strength and infrastructure. And we have to make our networking very stable, sustainable, and strengthening, using the One Health approach, so that we can address the issues by using all the aspects of the One Health. And in India, we have regulations, we have legislation, but the compliance is minimal. So we should be very strict about the compliance of the food safety regulation. And we need to be generate, or we need to create the capacity building regarding the risk assessment modeling, which is nowadays is one of the most advanced form of the risk assessment. And of course, we need to create awareness on importance of safe and nutritious food to the population, because in developing countries, the population is growing at a constant pace. So we need to feed them. We need to be very much conscious about the increasing demand or changing demands of the consumer. So that aspect we also need to be get strengthened. And this is all about for my presentation. Thank you very much. Next, please. Dr. Bilas?
Good quality and hygienic meat will be supplied to the global consumers. So I thank profusely Dr. Bedi for accepting our invitation for delivering this today's talk. And besides your ill health, okay. So today also you are not looking fresh.
Yes.
Okay. But you have made today's talk. You have delivered on the regulations and the risk assessment of the chemical residues in animal origin food. So thank you so much from my side and my team from the NAHED. Thank you so much, Dr. Bedi sir.
Thank you, sir.
So if there is no any, thank you. If there is no question to the Dr. Bedi, I think it is very clear to all the participants.
I
Now
have one
we can
question.
move to the next speaker. Hello.
Yes, sir. I want to ask Dr.
Anybody
Bedi
is
one
having
question.
questions, you can just introduce yourself. You tell your
Yes, sir.
name and then you can.
I'm Dr. Mudassar from Skos, Kashmir. Sir, thanks for an excellent and elaborate lecture on pesticide or the chemical residues and their prevention, and specifically about the risk assessment. So my question is that there are high-end technologies like gas liquid chromatography or HPLC or gas mass spectrophotometry. But are there some basic techniques wherein we can detect these chemical residues in foods? The basic techniques where we can only go for qualitative evaluation of these chemical residues in foods.
Yes, Dr. Mudassar, thanks for a very nice question. Nowadays, there are availability of a lot of rapid diagnostic kits, which are based upon, some of them based upon the ELISA, or some are based upon the lateral flow assay, by which you can evaluate the presence or absence of the chemical contaminants in food. For example, that we are also using in some projects the antibiotics detection kits based upon the ELISA technology, and aflatoxin detection kits on the base of the ELISA technologies. So these can be easily detected by using, you can say, less infrastructure, or not you need a lot of funds to purchase equipments. You can validate those kits in your lab, and then you can use them, and then you can give your results. But regarding the pesticide residues, the food safety regulatory authorities, they are very strict, and they have given their own guidelines that the results of the pesticides residues are acceptable only when you follow their guidelines, or you follow their method of processing, or you follow their method of the analysis of the residues, and you are using gas chromatography for a screening purpose, and gas chromatography mass spectrometry for your confirmation of the pesticide residues. For pesticides, there are restrictions are very stringent, but for other chemical contaminants, you can use the available rapid diagnostic kits. They are available.
Thanks, sir, and wish you, sir, speedy recovery.
Thank you, Mudassar.
Yeah. Yeah. So, Dr. Mundasar, what Dr. Bedi sir has told, it is very correct. Okay. So, what are the different uh, methods available, like ELISA based, some other kit based, or some qualitative tests like titration tests are available. But these tests using for the identification of the residues are not sufficient. Okay. So knowing that only whether antibiotic is present, pesticide is present is not enough for declaring that meat is free of any chemical residues. Okay, we should know that what is the quantity of or quantification of that residues. For that reason, we have to use a very sophisticated equipment like what he said, the GC, GCMS, GCMSMS, LC, LCMSMS. Okay, these are the sophisticated equipment. We have to see that, and we have to check that their levels or concentration of these chemical residues in animal origin food, so that we can conform to the national level standards or the international standards, so that we can send our product abroad. Okay, so this is very, very important. So the chemical residue, you know that it is cumulative accumulation of that product, chemical residues in animal product. So knowing that only merely it doesn't serve our problem. We have to have check the its level of concentration present in that particular product. So on that basis only we have to say that it is chemically safe, that product. Okay. So
So
any
actually,
questions, or we
lots
can
of
move to the next? Already we are late.
okay, sir, we may discuss it some other time,
Hello.
sir.
Yeah, you are most welcome, Mudassar.
Okay,
You
okay,
can
okay.
email
So
me or
we
you
are
can
late
contact
by
me.
half an hour. So yeah,
Okay,
and
sir,
Dr.
sir,
His
fine.
number is also there, his email ID is also there. We can share, and any participant who would like to discuss with him, he will be available. Okay. Thank you so much. So
Thank
we'll
you, sir.
move to the next speaker, Dr. S.P. Chawla. He is a scientific officer, G in Food Technology Division, BRC, Mumbai. So he has a very rich experience. He has worked more than 35 years in the BRC. Dr. S.P. Chawla sir, he joined Food Technology Division in BRC in 1990 after graduating from the University of the Mumbai. He received his PhD degree from the University of Mumbai in the 1999, and he worked as a RCA postdoctoral fellow in Korea Atomic Energy Research Institute, Daejeon, Korea. And his field of research interest mainly includes the preservation of meat products, using the radiation processing, development of methods to identify irradiated foods, development of the natural food additives and active packaging materials for the food applications. He has authored over 60 research publications. Dr. Chawla is retired as a head, Meat Technology Research Group, Food Technology Division, BSc, in October 2021. That is not by superannuation, but he has taken uh, voluntary retirement. Okay. So Dr. Chawla is very close to our department. Okay, we had different research programs along with him also, and we have standardized the different gamma irradiation doses mainly used for the extension of the shelf life, and then that data which was already we have submitted to the government of India, and it is published in the BIS as an standards for the using these irradiations for the animal origin food. So with that, I invite Dr. Chawla sir to present his topic on the use of the gamma irradiation technology for the extension of shelf life of meat. So Dr. Chawla sir, please.
Hello, good afternoon. I believe audience may be not aware of radiation processing technology. So I'll give a brief about what radiation processing is there. Next slide, please. Okay. Where see, we all know about electromagnetic radiation. There are different types of radiations available in the nature, and most of them we come across in our day-to-day life: radio waves, then visible light, infrared, X-ray. Now, up to visible light, we are using in our day-to-day life. From X-rays, X-ray also we get exposed for our therapeutic uses, and shorter than that are gamma rays, and these are the radiations. These are ionizing radiation which are employed for preservation of food. Okay, the next slide, please. Now, for radiation processing of food, there are three types of sources approved. One is gamma sources, in that cobalt-60, which is a radioisotope of cobalt, and cesium-137, which is the isotope of cesium. They are used for electron beam, 10 million electron volt of electron beam, X-ray, which are having an energy level of 7.5 million electron volt. These are employed for radiation processing of food. Basically, wherever the exposure is carried out in a controlled in a shielded manner, where a operator or a environment is not exposed to any radiation. Okay. Next slide. So you can see in the center the radiation source is there, and product takes a pradakshina. What we got, when we go to temple, just we move around the god. Similarly, the product moves around the radiation source, and during this process it absorbs some energy which is emitted by the radiation source, and that is the energy which is causing certain changes in food, and that enhances the shelf life or whatever changes are, and you can see, it is just exposed, so it is never coming in contact with the actual radioactive material. So next slide, please. So what we can achieve by radiation. Okay. So radiation can do number of things. Broadly, they can be classified into low dose, medium dose, and high dose application. Basically, as I told you, radiation means is absorption of energy, and that absorption of energy unit is called gray, which is equal to 1 joule of energy, which is absorbed per 1 kg of mass. So when we say low dose, that means it is less than 1 kg gray, less than 1,000 gray, and medium dosage is between 1 to 10 kilogray. That is from 1,000 to 10,000. And about 10 kilogray, it is called high dose application. So low dose application include sprout inhibition, like in onion, potato, ginger, garlic. If you have seen, when they are stored for a long time, there is a sprouting. So that can happen. Similarly, in case of grains and dry products, insects develop. That is because of growth of insects. And again, in case of fruit, ripening can be delayed. And when we are exporting this fruit from one country to another country, there is a probability along with that fruit, whatever the pest, one insect is there in that fruit, can also go to the importing country, which is not needed by that country, because they don't want that exotic insects to come to their country. So this is one of the most important application right now being carried out. I'll give you example of mangoes. Now, Indian mangoes, which are loved by throughout the world, and basically our Indians, which are residing in outside country, they need mangoes. They want to enjoy those mango. But what happens when Indian mango goes there? There is a probability that along with that mango, that insect will go. So when a item is going from one country to another country, that time they have some this thing agreement between buyer and seller. And now in US, Australia, these are the two countries which they allow entry of Indian mangoes only after radiation treatment. Okay. And again, that this is again doses are all these applications what I've talked about. They are low low dose. So the dose is used between 0 to 1,000 gray. Okay. Now, medium dose application, when we say 1 to 10 kilogray, those include hygienization of spices, where 7 to 10 kilogray, shelf life extension of meat, again around 4 to 7 kilogray. These are the things which are used. And high dose application where we are preparing self-stable product using radiation technology. It is equivalent to canning. How we use heat treatment to eliminate all the living microbes. Similarly, we can do that with the radiation also. Next slide. Now, I am not going into much detail. We all know, you people are from veterinary background, that India is among top producers of meat and chicken. Advantage include competitive pricing. We don't have BSC problem. We are not using hormones, so meat is lean meat. We are following halal techniques, so that again that is accepted throughout the uh, world. And we are a major exporter of buffalo meat. Our major importing countries are UAE, Saudi, Oman, Egypt, Iran, Malaysia, Indonesia. These are our major customers. Next slide, please. So what is the importance of meat and meat products in our diet? They are important part of diet because we like that flavor, texture, and nutritional quality. Because that uniqueness, certain things are there in meat which are not present in vegetarian. So again, they are very good source of high quality protein. They have certain polyunsaturated fatty acid, vitamin, minerals. These are the important factors why people enjoy meat and meat products. Next slide, please. Now, we all know that when the animal is slaughtered, it is muscle is normally of healthy animal is sterile, but it gets contaminated because the organisms are present on the skin surface. And this during that slaughter process, the contamination occurs because of a person who is handling equipment, which a person who is handling environment. So these are basically contamination is of two types. One is spoilage bacteria like Pseudomonas, Acinetobacter, Pseudomonas, Lactobacilli, Clostridia. These are organisms which are responsible for spoilage. And second type of organisms are pathogenic, which are likely to cause harm to the consumer if they are ingested. Those include Salmonella, Staphylococcus, enteropathogenic E. coli, Listeria, Yersinia. Then parasites are also there in certain types of meat like pork, mainly uh, Trichinella, Toxoplasma. So basically, when we talk about meat spoilage, major of the spoilage occurs because of microbial growth. Otherwise, it is also enzymatic growth because animal tissue, it is having own enzymes, autolytic enzymes are there, which then act on muscle itself and hydrolyze the muscle, and it makes it more available for spoilage. And chemical changes, it is good source of protein and lipid. And these, along with the action of ultraviolet rays, oxygen, and whatever other factors are present in the environment, it will result into, it will undergo oxidative changes, which results in development of off odor, discoloration, and loss of texture, leading to formation of drip. Coming to preservation methods, most common for this meat and meat products is freezing. Then canning is there, reduction of pH, reduction in water activity, fermentation, and finally, main thing I'll be talking about, radiation processing. Now, so most simplest is chill temperature storage. Here, we know that see, basically spoilage is some reaction. It is biological and chemical reactions are there. When we are reducing the temperature, rate of reaction decreases, and hence we get extension in cycle shelf life. But still, if we are using chilling, the shelf life is less than 5 days, and in cold temperature, parasites and pathogens are not killed. They survive the storage and they may remain viable. Next, please. Next is freezing. Here, temperature goes below -20. So here, practically the enzymatic activity and bacterial growth is stopped, and chemical changes are minimized. And here you get a significant increase in shelf life. You get shelf life of over a month. But what happens during freezing? There is a loss of texture. It becomes hard. Then when that freeze thaw happens, that drip loss is there and costly. Now in country like ours, we have lot of issues with the power. Power is not available. So maintaining -20, it adds to the lot of cost to the product, and infrastructure is not there. Uh, Again, here also, even pathogens may remain viable in the food, and that is the reason that product may be always not safe for the consumer. Next. Dehydration, as we know, water is the most important component which is needed in what we have a saying, Jal hi Jeevan hai. So here the objective is no water, no growth. What we do, we remove moisture, reduce moisture, so that it is not available, water is not available, enzymatic reactions are minimized and microorganism cannot grow. But limitation is the product becomes hard, it dry. We don't like that sensory attribute. And during it takes if you undergo for natural drying, it is a long process, and lot of nutritional changes happen, and even pathogens may not be eliminated. Next is chemicals. Here, certain chemicals are used for inhibiting growth of microorganisms, which are some few of them are very commonly used, which include uh, common salt, sodium nitrate, lactate. Again, these products, you have to be very careful so that you optimize the dose without affecting the sensory attribute of the product. And these chemicals which we are going to use should be approved by the regulatory agencies. And many a times the product may still require refrigeration, pathogens may be not eliminated, and hence safety becomes a questionable. Coming to heat sterilization, it is equivalent to what we call autoclaving. It really eliminates all living forms, pathogenic as well as spoilage organisms. But many times what happens, certain meat products may not be amenable. There is lot of textile changes. Now, if you autoclave chicken or fish, it will become mushy, and a lot of vitamin loss are there, and that is the reason all the types of products are not amenable for retort processing. Coming to fermentation, here we are converting sugar to acid, reducing the pH, and it adds to the flavor of the product, as well as the texture is improved. Uh, Again, safety becomes questionable because pathogens are likely to survive the low pH. And finally, coming to radiation, now radiation, when we are whatever doses are recommended, it will kill most of the organism, not all. So, as we know, the microorganisms play a very important role. Normally, the meat has 10 to 2 to 10 to 3 organisms, and this during the storage, these organisms multiply, and normally the doubling time as a thumb rule is around 20 minutes. So if it is left at ambient temperature within 24 hours, the count will be 10 to 8 and meat will spoil. Now, what radiation does? Radiation reduces the initial microbial load by a couple of log cycles, and that is how you get the so and Uh, and that is how the spoilage is reduced and you get extended shelf life. And now when radiation is killing bacteria, it doesn't discriminate between spoilage and pathogenic. So pathogenic organism is also destroyed. And basically radiation is a process. The temperature increase is not there. So there is a negligible effect on nutrients. So all the biological use of nutrients are not significantly affected. Next. Now, everybody knows the concept of D10, that means one log cycle reduction. Okay. Now, in radiation processing, the DNA is a target molecule which is affected. What radiation does, it breaks the DNA of the bacteria, and that is the reason it cannot multiply. and the dose required to kill 90% population is known as D10. Okay, now this sensitivity of organism will depend on uh, stage of species. Normally, as a thumb rule, gram-positive organisms are more resistant. Stage of growth, organism is more sensitive during its exponential phase. Composition of media, presence of oil and fat, protein enhances, decreases the radiation sensitivity. Moisture content, dry product will be more resistant. Atmosphere, presence of oxygen enhances the effect of radiation. Next, please. Uh, in case here, extension of shelf life, here the product is exposed to radiation at chill temperature, and normally 2 to 3, as I told you, 2 to 3 log cycle reduction in microbial load is there, and that is how the shelf life is extended, and also the microbial quality safety is improved, and it is energy saving. So, and you get shelf life around. In case of mincemeat, you get around 1 week, and chunks you can get 2 weeks, and much bigger pieces you can 3 to 4 weeks. Here, what happens rather than -20, if you can store a product at +3, so you are seeing a lot of energy. So it is more advantageous for country like our that energy is saved, where energy shortage is there, and another is texture of this product. We as a Indians, we all normally prefer a fresh like meat. So that frozen meat texture, which is not appealing for most of the consumer, it can be eliminated, and this is useful for where the a proper supply chain is there, like and temperature maintained is there. You can always plan your weekly sales and all those things accordingly. Now what happens in superstore, because that chilled chicken, if you take example, the shelf life is 3 days, and so within 3 days it is not sold. And if in case of irradiated chicken, you are getting shelf life of 2 to 3 weeks, that is a huge advantage for both the consumer as well as the processor. Next, coming to hygienization, here, radiation doses of 7 kilogray can eliminate most of the non-sporulating pathogens like Salmonella, Shigella, Yersinia. All these pathogens can be taken care of. Now, this is more important in ready-to-eat products, the products which are just microwave for a couple of seconds or minute, 1 minute, and they are consumed. Here what happens, and these are made in very bulk quantity. Now nobody cooks at home. Now, if these are contaminated, they will cause affect lot of consumers. So this is one of the process which is very important safety point of view, and it is being used in many of the advanced countries for ready-to-eat products. And third is high dose application. Here, this process is equivalent to canning. Here, see, the process involves preparation of shelf-stable meat products which can be stored at ambient temperature. Now, here the process involves pre-cooking. Here, yeah, as I told enzyme, oxygen, and microbial growth. These are the three things which are going to spoil any food. So, what we are doing, we are pre-cooking, where we are giving a blanching like steaming treatment, so that to inactivate the enzyme. Second step is vacuum packaging, by virtue of which you are eliminating it from interaction with the atmosphere. So that package, it is what we employ is a multi-layer package. So there is no moisture loss, no oxygen transition, no UV radiation exposure. And since the this thing is there, and then we freeze the product to -30 and subject to irradiation dose, which is sufficient to kill 12D this thing of Clostridia. So we give dose which is equivalent to canning, heat treatment, heat treatment, so that no bacteria is surviving. And these products are safe, and they are being used by astronauts. These have a lot of potential applications for defense forces, mountaineers, relief operation. That immunocompromised patient whose immunity is down, and even one organism is detrimental for their health. So these are the potential applications. These are some of the Indian products what we had worked in BARC. You can see chicken pie, kebab, chicken tikka, pulao, paratha, and these are the products which can remain at ambient temperature for more than 1 year. Next, please. Second concept is Huddle Technology. Here, we need a safe product which can be stored at ambient temperature. Here, we are using combination of reducing water activity. So, here is you reduce the water activity to around 0.85. Now, 0.85 is significant because none of the pathogenic organisms will grow at that moisture activity. And again, it is not very dry. So it is intermediate moisture, and you give radiation dose. At this water activity, main culprit of spoilage is fungus. So that can be eliminated by radiation. You can develop a product which is self-stable at ambient temperature. Again, dry meat products are there. Yeah, there also insects are developed, and here doses up to 1 kilogram can be employed to take care of insects. Next, please. This is one of the major application which is currently employed by most of the industries. Now, pet food and feed byproducts of meat processing industry have lot of export potential. India is one of the uh, top exporter of these products. But when they are importing products, these being byproducts and hygiene quality is not very well maintained in our country, and importing countries have their own microbial standards, so it should be one of the major thing is it has to be salmonella free. So radiation treatment is one of the best treatment for this type of requirement. Now coming to hygiene again, my previous speaker also spoke about surveillance and all those things. Now, meat and poultry, these are because they are coming from live animals, their skin is contaminated, which is exposed. And many of the food poisoning cases have been reported in developed countries. In India, as he told, we have many times lot of food poisoning. We just ignore. Okay, because we don't have a proper surveillance system, documentation is not there. Fortunately, our cooking habits, we have a habit of cooking it properly. We cook it in pressure cooker, mutton or chicken will boil for 15-20 minutes, and during that process, bacteria is most of the organisms are killed. So that is how our cooking habits save us from a lot of uh, with the things are changing. Now we also get lot of ready to eat, ready to cook products, which if they are contaminated with the pathogen, we are likely to get the disease. So radiation has a role to play. I'll give one example: E. coli 15787. This in the carried a caused outbreak involving 500 people, and few people died. And this is because that hamburger, consuming of hamburger, it was which was undercooked. So that time temperature of cooking is very important. And India, though we don't have any system to right now to monitor these things, so it traces the reason, and that is how the E. coli became a problem. And in US, in 90s, it caused havoc. And this is a organism when it is infecting, it mortality rate is pretty high. And it, as I informed, that it was due to a hamburger. So uh, when the source was traced, it was found that it was a hamburger which was contaminated with E. coli, and they had to recall all the material from the market, and had to destroy. So a few of the companies went bankrupt because see that they are processing in huge volume, and it is not like that one lot is. It is the entire lot which is present throughout the country from that same producer. And again, once you are declared that your product was contaminated, it is a reputation which is at the stake. That companies went bankrupt, and then the mechanism started moving. In 1997, US FDA allowed the radiation processing of red meat, and in 1999, USDA Now in US, there is, along with the US FDA, US Department of Agriculture is also, in case of meat, they also have to approve. So after that, in year 2000, ground beef started appearing in supermarkets, and in 2001, more than 22 states, there was availability of irradiated meat products in more than 2,000 stores. So this is about the process and this thing. Now coming, as a consumer, basically for any technology, the consumer is the most important person to accept the technology. Now, the first question when we talk about the name title itself, when it is radiation, people get scared. They confuse the radiation with the radioactivity. So as I showed, it is never coming in contact with any radionuclide, so contamination is not possible, and induction of artificial radioactivity. Now in beginning of my presentation, I told that there are these sources which are approved. So those sources which are approved for radiation processing of food, with whatever those food is exposed, they cannot induce any radioactivity. So that is a take-home message, that whatever sources have been approved, these are based on certain guidelines. The energy levels are so low that they will never induce radioactivity. So that fear is not needed. Now, next is nutritional. What happens to nutritional quality? Now, see, as I told, it causes certain chemical changes. Some new compounds are formed. Some chemicals are added. Uh, it is very small fraction the changes are there, and these changes are equivalent to what happen in food. Now formation of certain acids, aldehydes, ketone, these are normal process when you store any carbohydrate rich food or heat it or keep it for longer time. So these things are that there is no unique radiolytic product. Okay, next please. In case of protein, again, biological value is not changed. Primary structure of protein are not changed. So biological value remains same. Whatever essential amino acids are needed, they are there. Only that secondary and tertiary structure is disrupted, which has nothing, no role for biological value. So in case of vitamin, there are certain vitamins like thiamine, vitamin E. They are radiation sensitive, and their content because of radiation, and that is equivalent to what happens during the storage or heat treatment. When we heat, vitamin B1 is also very heat sensitive. Similarly, same is true with D also. So whatever changes or decrease in nutritional quality of certain vitamins happen is equivalent to what happens in the other food processing method. Again, as a lipid oxidation, now there is a formation of certain uh, hydrolytic products in protein, declining some, and there is, as I told you, this radioactivity is not induced, or even microorganism, their characteristics mutation is not happening, because the dose which is employed, it kills the bacteria. There is no opportunity for them to mutate or form something. So new, and whatever new compounds are formed in due to radiation of carbohydrate, protein, lipid, they are same compounds which are normally formed because of say radiation, extrusion, or any other process, dehydration. They are uh, similar compounds. So there is no new compound which is formed and which is harmful to the consumer. Next, which is formed and which is now safety. Now radiation processing of food is one of the technique which has been scrutinized for last more than 100 years. Okay, in 1981, WHO, FAO, IAEA expert committee, they recommended that doses up to 10 kilogram safe. And again in 1994, because in 81 there was no data on doses above 10 kilogram. So 94 again, that when they scrutinized the data of nutritional adequacy of doses above 10 kilogram, and finally in 1999 they gave this JICFI, Joint Committee, they gave a recommendation that what is known as sky is limit. Now, the limit other than the national each country has their own regulation, but scientifically when we say there is no limit for radiation processing of food. The radiation processing of any food commodity is dependent on uh, see, there are two factors. One is technological purpose, and second is sensory quality. Technological purpose, suppose I want to eliminate insects, so I will give a dose which is required to eliminate insect. So I am not interested. And second important thing is, since I am talking about food, it has to be acceptable by the consumer. So if my process is giving me serving the objective what I want to do, and it is not acceptability of my product, so there is I can use that process. This is not only for radiation; it is applicable to any technology, because when we are giving any treatment, there is something we are changing, and that in case of food, that should not have any adverse effect on the consumer. Next, please. Now, we have a lot of, we say whether these things are endorsed by international agencies. You can see that radiation technology is endorsed by all international agencies like CDC, FAO, Codex, USDA, USFDA, American Medical Association. So these are the international agencies who have scrutinized all the data, and they stand by that this technology is safe and it can be employed. Now, again, I will summarize that education and safety of irradiated food. Radioactivity is not in use. There is no problem with the microbial changes. There are no unique radiolytic product which is going to cause harm. Whatever products are formed which are equivalent to what they are formed by other food processing method. Vitamin losses are again comparable to other processing method. And basically many of the approvals initially when they do animal feeding studies and all those things. Now US and China, they went ahead with the human trials, and after that only they approved that yes, it is safe. And now as of today, more than 60 countries including India approve radiation processing of food, and over 100 food items have been approved. And if you next is a list of countries approving food irradiation program, and you can see all types of countries, as small country, big country, rich country, poor country. It starts from Bangladesh, Chile, China, Costa Rica, everything, and advanced countries like USA is there, UK is there, France is there. All these countries are approved. Coming to India, India, our governing body is FSSAI, and you can see in 2016 we have got that class-wise clearance. Now, this next slides will be showing the list of things. You will see broadly all the food commodities which we consume are divided into 8 classes. Okay, classes, and uh, literally everything is present which we are eating, and everything is approved. So there is nobody is doing anything illegal. Uh, See now, class one is bulbs and tubers. The purpose, it shows class of food, class number, food, purpose, why it is being inhibited, and what are the doses to be employed. So similarly, and if you talk about meat, meat comes in class 5. So with the objective to eliminate pathogen, you can give dose up to 1 kilogram. For shelf life extension, you can give up to 2.5 kilogram, and to eliminate pathogen, you can give up to 7 kilogram. So those things are there. So literally all the foods are there in class 8. Special food 25 kilogram is also permitted. So uh, use radiation as a process to preserve food and enhance the safety of the microbial safety of the product. Next, please. Now, apart from that, certain allied products are there which are also approved. Here, these are the products which are being mainly used right now. Pet foods are there, agricultural by herbal products, food additives, and all these things are being irradiated in very high volumes in our country. Now, in 2018-19, FSSI gave a guidance note for safety of irradiated 2019 This is available on internet. Anybody can always go through and see whether what FSSI talks about it. And this next slide is about radiation processing plants, which are right now functional in our country. There are around 20 plants, and they are throughout our country. They are many are concentrated in and around Mumbai. Then Delhi region is there, Hyderabad South is also there, Bengal is there, Rajasthan is there. Everywhere plants are there. And these are the facilities which are functional. If you see, the first facility was built in 2000 and now it is 22. And right now, even this couple of plants, one is high media. Everybody knows high media. High media set up a plant in Ambernath, which will be commissioned shortly. Then one Akshar Gamma Tech is also coming in Ambernath. And again, AV processor Sterico, they are also coming up on more facilities in Amarnath. So Amarnath itself has a 4 irradiation processing park. In Vashi, we have 2. One is owned by Maharashtra State Agriculture Marketing Board, and one is by BRIT, which is part of Department of Atomic Energy. And of these 4 facilities have been approved by USD, USD agency, which is allowing import of mangoes. So as I told you, mangoes, when they are going from India to US, they want mangoes, but they don't want our insects. So this is the only treatment has been approved for taking care of what they call quarantine treatment. It is approved by both the countries. And coming to the what question most of you will have as a this thing, can irradiate spoiled food marketable? So answer is big no. See, food is already it is spoiled. It is, as I told, it will kill bacteria. If toxin is present, it is already spoiled. Texture has changed. It is not going to do anything. It will and if you are not going to handle it properly, it will again get contaminated, and it will not improve the poor quality flesh product. It will, if it is spoiled, it is smelling bad, that smell will be still there. So it cannot be used as a malpractice. It should not be never used as a cleanup technology. But yes, we know, in spite of all the GFP and all, we are facing problem now. US, as I told about E. coli example I gave, in spite of best of hygiene, they face a problem of E. coli, and this was the only technology which could be employed. So, radiation processing can be used as a final critical control point after processing, because radiation has a very good penetration power, and you can irradiate in a finished product because it can penetrate. There is no issue. Radiation will penetrate whatever package you have. It will do its job, and you will get a microbiologically safe product. And now coming to what are the commercial potential. Now, right now, if we talk about uh, radiation processing, a lot of material for poultry food and feed and fish meal, pet food, these things are being irradiated in most of the facilities. So, flesh food, meat products, and as you know, they are temperature sensitive. You cannot keep at ambient temperature. And as per the rule, if you want to maintain that cold chain, it is there are a lot of logistic issue presently. Right now, even during irradiation, we have to maintain that minus 20 or plus 3, whatever chilled and frozen temperature. These facilities are right now not existing. And thing is like this, that as a researcher, we say that industry has to come to us, and industry says, where is the researcher? So who will bell the cat? So it is basically, I personally appeal all the participants who are from industry, they should interact more, try to understand more about the technology, and try to work out the field can be taken to international trade. Okay, how it can be commercialized. Now, as far as trade, as I do know, there are specific barriers, phytosanitary, cyto and phytosanitary treatment. Suppose if somebody now, why mango is being irradiated? Because US is saying that mango should be free of insect, and you have to follow this protocol. Similarly, if you are I think just at the time of lockdown, I got a call from one exporter from dry fish exporter. He had a issue. He says that sir, मेरे को वो यूरोप का कंट्री में भेजना है, वो बोलता है आप irradiate करके भेजो. And I told him that it can be done. So he went to Washi, got irradiated and sent. So that opens a new business channel for entrepreneurs. So that wherever the hurdle is there, yes, we have to work like that. If that hurdle, microbial hurdle, can be taken care by radiation. How? And we have to, in as a see, until unless industry says that yes, we face this problem, researcher will not focus on them. Now, what happens when researcher is carrying out research in an institute? He says that I will say yes, this is happening. Whether logistically, for scale up, it is possible. It is the you guys who are going to tell yes, and now students and other participants, academicians who are there, they have to pass on the message about this technology to the students, and this message is to press that potential is there for this technology, and it is being used throughout the world. Now, China has around more than 250 radiators. Their logic is we are not going to waste a single grain of food. Our objective is not like that. Being a democracy, we don't mind wasting food, but we will not adapt to the technology and make the changes. Now, many times these regulatory approvals, what happens now, as I told you, approvals are different. Now in India, so in 80s, there are approval that radiation can be done only for uh, export export material. So that doesn't make sense. Any importing country, when you are not consuming, why I should consume? So those things are there. So when uniform regulations are there, things will work out faster. And next, now, as I told you, then because transportation is difficult, we have to make facilities which can be integrated with the production line, or set up e-beam facility, or set up a facility at port of exit. Suppose you want to export a consignment. So from where your consignment is getting exported, at that port or facility, if that the radiation processing plant is there, you can irradiate and then directly it can be uh, shipped to the cargo, and it goes to the country where it is going. To summarize, next please. So radiation has a potential in enhancing food safety, extending shelf life, and promoting international trade. Next, please. And this information, as Dr. Jende already informed, I have retired. So these are information during my working period in BERC. My colleagues from my lab and division, they have given input. So thank you. If you have any questions, you can ask.
Thank you, sir. Sir, one question is there: approximately how many days shelf life be extended by low irradiation mechanism in buffalo meat, vacuum packed buffalo meat?
See, vacuum packed buffalo meat will already have a good shelf life, and if you use radiation, it will at least increase 2 to 3 fold more.
Thank you, sir. So, any other question? Any participant want to ask any question? You can ask. Otherwise, you can write in the chat box also.
Good afternoon, sir. I'm Dr. Mahesh. After radiation tech, can you hear me, sir? Hello.
Yes, tell me. Yeah.
After radiation technique, it destroys the microorganisms. After killing microorganisms, is there any toxin liberation by microorganism in the meat? Is there any residual effect on that meat?
No. Once as I told you, if toxin is preformed before the killing of bacteria, that toxin will remain in that. So that is the reason this is not an alternative to GMP.
Okay, sir.
Okay.
So,
If
so how
toxin is
can
removed,
this residue is can be eliminated all
which
from
residue?
all
No. Toxin once formed cannot be eliminated.
Okay, sir.
You see, that is what I saw. It is not a cleanup process where you are not using any hygiene and then reducing the bacteria. No, you have to follow GMP, but still, if bacteria is there, you can eliminate that bacteria. And for shelf life, it will now, as I told you, these burgers and all which they recommend, if you just microwave for a couple of seconds and you can consume 30 seconds, 60 seconds, and you can consume. If such product is having salmonella, and because you might have observed that microwave cooking or heating, rather not cooking, it is microwave heating, is not uniform. So there are certain cold patches and bacteria is present there. It is definitely going to cause a harm. Fortunately for country like ours, we don't do any tracing. Now, as I gave you example of US hamburgers, they traced out that why it has happened, why that E. coli came into the system because of undercooking of hamburger.
Okay, sir.
Okay.
Okay, sir. Thank you, sir.
Thank you, sir. Any other question?
Thank you. Sir, is this process is economical for a normal industrialist in India?
See, normally meat nobody has done. Meat fresh, fresh meat and all those things. But whatever facilities are there, whatever calculations are, any process, it will cost around 5 to 10% of the product cost. So if you are taking a benefit of cost benefit, you are saving on energy, you are getting safe food. It is a commercial call, has to be taken by the entrepreneur. Now, as I told you, pet food. Most of the radiation plant facilities, around 40 to 50% material which is being irradiated is a pet food.
Thank you, sir.
Okay, thank you, sir. Thank you, sir. Thank you very much, sir. Thank you, sir.
One more question. Anybody want to ask?
Okay. So there is no further question. We can wind this talk. I thank Dr. Chawla sir for giving the all this about the food demand and
Thank you, sir. Nice presentation.
and bad quality meat with good quality meat. So I will say that it's like over 60. So this meat is good quality. So after this, okay, thank you so much. So such kind of irradiation such kind of are also available across the country. There are 20 plants already available there, and anybody, any entrepreneurs, they can come for and contact me or the BLC people, so that we can develop certain kind of the plants for the irradiation purpose of your desired product. So that can be done. So I thank Dr. Chawla sir for nice presentation today and our accepting our invitation for today's presentation. So I declare this today's program is over. Thank you so much.
Thank you, sir. So I request all the participants to join tomorrow at 10:50 a.m. Tomorrow again we will have 2 lectures. So all are requested to join tomorrow at 10:50 a.m. Thank you.